Happy birthday to you. Happy birthday to you. Happy birthday, happy birthday, happy birthday to you.
Hello students, welcome you all to another session of Amazing World of Science where you learn NCERT line by line for classes 9 to 12. So after a short gap due to some personal issues, I could not post the sessions and I really apologize for that. So today we will do class 9 NCERT chapter 3 atoms and molecules. So as you all know, this is a very important topic and only if you have a deep knowledge with the concepts of this portion, you will find chemistry really easy in your upcoming higher classes. So we will start the session. First of all, we will have a short introduction about ancient Indian and philosophers who always thought about unknown and unseen form of matter. So as you know, matter is something which occupies space and has got weight, and the idea of divisibility, that matter can be divided. So it was considered a long time back in India, that is around 500 BC itself. So an Indian philosopher known as Maharshi Kanad, he said that if you go on dividing matter, what he called as padarth, you get smaller and smaller particles. See, matter can be divided into smaller particles, and a time will come you can see the smallest particle. So at that point you cannot further divide the particle into any more, that is the last division of matter. So he called those particles Paramanu. And another Indian philosopher known as Pakuda Katyayama, he said that the particles normally it won't exist independently, but it remains in a combined form. So from that combined form it gives various forms of matter. So in along that same time, around that time, some Greek philosophers called Democritus and Leucippus, they said that suppose you go on dividing, that is partitioning or cutting matter into next steps, the particular stage will come and at that stage you cannot divide the matter or cut the matter into any more. So those indivisible particles known as what they said is that these all these concepts were based on considerations and not much experimental work were done. See, in science, regarding science, whenever you get a theory, you have got to prove them experimentally and validate it. So these could not be validated till 18th century, and by the end of 18th century, scientists found out that the difference between elements and compounds and all these things, you know what are elements, and elements combine to give you compounds, and they got interested, why do these elements combine, what happens when they combine together. And another scientist called Antoine Lavoisier is a very famous person, scientist, and he was the one who laid the foundation of chemical science by forming two important laws known as laws of chemical combination. So laws of chemical combination, there are mainly two laws. The first law being law of conservation of mass. From the name itself we can say conserving mass, preserving mass. So what does it mean, conserving mass? It's nothing, it says that matter cannot be created or destroyed in a chemical reaction. That is, matter can get converted from one form to another, but you cannot create it or destroy it. Now the second law which was found was the law of constant proportion. That is, Lavoisier with some other scientists, they noticed that many compounds were made of two or more elements, And see, when elements combine, as I already said, they form compounds, and each compound had the same elements in the same proportion. So whoever prepared it, wherever the elements came from, when they combine together, like for example, if you take the case of water, water has got hydrogen and oxygen. So always the mass of hydrogen to oxygen is 1:8. One part of hydrogen combines with 8 part of oxygens. Wherever you take water from, anywhere in the universe, wherever you take water from, then the combination of the elements will be the same ratio wherever it comes from. And suppose if you take 9 gram of water, you decompose it. From that you will get 1 gram of hydrogen and 8 gram of oxygen. Similarly, ammonia, what is ammonia? NH3. In NH3, always the ratio of nitrogen to hydrogen will be 14:3 by mass from whichever source you get. So, from this observations they validated and they formulated the law of constant proportions, which is also known as law of definite proportions. So always what does this law say? It says that in a chemical substance, elements are always present in definite proportions by mass. So what happened after this was the next problem scientists had to face was to give explanations for these laws. Why does this happen? Why they always remain in a fixed proportion? So another scientist called British chemist John Dalton, he said the basic theory about the nature of matter. So Dalton said that the idea of divisibility of matter, till then it was just a philosophy. He said he took the name atoms, which was given by Greeks, and he said that the smallest particles of matter are atoms. So it was based on the theory on the law of chemical combination, and Dalton's theory gave an explanation for the law of conservation of mass and law of definite proportion. So according to Dalton's atomic theory, there are a few postulates or a few theories based on that. That is, what does it say? All matter is made up of very tiny particles called atoms. So atoms combine to form or the basic constituents of matter is atom, and you cannot divide it. Atoms are indivisible. That is why we cannot create it or destroy it in a reaction. And for a particular same element, the atoms are similar. Okay, they are identical. And also next postulate is that what is the first postulate? All matter are made up of very tiny particle called atoms, and these atoms are indivisible. It cannot be created or destroyed. Atoms of same elements are identical in mass and chemical properties, and different elements, atoms will have different masses and chemical properties. Atoms always combine in the ratio of small whole numbers to form compounds. For instance, see in NH3, 3 parts of hydrogen will combine with 1 part of nitrogen, and always the relative number and kinds of atom are constant in any compound. If you take H2O water and 2 parts of hydrogen and 1 part of oxygen, it's always same, always constant. Now we will learn, I hope you found this part clear, and we explained about various postulates, and we discussed what is meant by law of constant or definite proportion, and then law of conservation of mass. All those things you might have understood. Now we will move on to our next topic, what is an atom. So see, you might have seen a mason building walls of a room. So many bricks they use to build a building. So the building block of the huge building, suppose if you are given a small grain of sand or whatever it is, all matter are atoms. So how big are atoms? These are very small, smaller than whatever you can imagine. Okay, more than millions of atoms, if you stack it, they would be very small layer, barely as thick as this thin sheet of paper. Okay, and mostly atomic radius is measured in nanometers. That is 1 nanometer is equal to 10 raised to minus 9 meter, or 1 meter is equal to 10 raised to 9 nanometer. Now you will think that if atoms are so insignificant, then why should you care about them? What is the purpose of taking into consideration such small things, because the entire world is made up of atoms. We cannot see atoms, but they are there. Whatever we do, they affect all our activities. So through modern techniques, now you can produce magnified images of surfaces of elements which shows atoms. Now next, after finding out the atoms, it became necessary to give them symbols, because all the time you cannot use the names, and when you write chemical equations and all that, it's better to have something shorter. So that is how the idea of symbols came. So Dalton proposed the first ever symbol for different atoms, and Berzelius said that symbols of elements can be made from 1 or 2 letters. See, in olden days for hydrogen it was like this: carbon, oxygen, see, phosphorus, sulfur, iron, all these are different symbols. Okay, and these symbols were proposed by Dalton. Okay, now in the beginning the elements names were derived from name of the place where they were found for the first time. Suppose copper, it was taken from Cyprus, and some names are taken from the colors. For instance, gold, it's taken from the English word meaning yellow. So nowadays IUPAC, as you know, International Union of Pure and Applied Chemistry, they have to approve the names of elements. So many of the symbols are first 1 or 2 letters of the elements name in English. First letter of a symbol is always written as capital, that is uppercase, and second letter as smaller case. See, for example, hydrogen, what is the first letter? H. Okay, that should be taken as capital. Now for aluminium, we take 2 letters. First A should be capital and L should be small. You should not write both as capital. For cobalt, first C capital, O is small. Both should not be capital. And some elements have got their symbols formed from the first letter of the name and letter appearing later in the name. For example, chlorine, you don't take CH, you take Cl. For zinc, you don't take Zi, you take Zn, like that. And mostly symbols are taken from names of elements in Latin, German, Greek and all that. For iron, it is taken from the Latin name ferrum. Sodium, Na from the name natrium. Potassium, K from the name kalium. So each element has a name and a unique chemical symbol. Yeah, see, you should surely learn all the elements. It's difficult to learn all the elements, but the first at least 20-25 names and symbols you should remember, write and learn from this table which is given in your textbook. Okay, now atomic mass. So the remarkable concept put forward by Dalton was the atomic mass. So according to him, each element has a characteristic atomic mass. So that is why the theory could explain the law of constant proportion. So the scientist should measure the mass of the atom. Okay, defining mass of an individual atom is very difficult because of the very small size. So the masses were determined using the laws of chemical combinations and compounds formed. For example, if you take a compound carbon monoxide, it is formed by, you can see, like carbon and oxygen. So experimentally it was found that 3 gram of carbon will combine with 4 gram of oxygen to give CO. That is, carbon combines with 4 by 3 times mass of oxygen. Suppose you define atomic mass unit, that is AMU, but according to latest IUPAC recommendation, it is now written as U, unified mass, which is equal to the mass of one carbon atom. Then it would be whole numbers or as near to whole numbers as possible. See, always it's very easy to represent the mass and all in whole numbers. So for searching various atomic mass units, first of all, scientists thought to take oxygen 1 by 16th the mass. Why? Because oxygen is naturally occurring element, and it's present in most of the compounds. So oxygen also reacts with large number of elements and forming compounds, and atomic mass units will give masses of most of the elements as whole numbers. But in 1961, a universally accepted mass unit was taken with carbon 12 isotope as a standard for reference to measure atomic mass. That means one mass unit is mass unit equal to exactly 1 by 12th of mass of one atom of carbon 12. See, carbon has got different isotopes, okay, 12, 14 and all that. So carbon 12 was taken as standard, only then 1 by 12th you will get a somewhat whole number value, and all the atomic masses of other elements were found with respect to that of carbon 12. So this is a very important concept which will come in higher classes, so thoroughly learn this. Okay, so now carbon 12 isotope is taken as a standard, and suppose you see you are going to a fruit seller, he is selling fruits without any weight, he doesn't have any weight with him. So what he does is that he takes one watermelon and he says that this has mass equal to 12 units, that is 12 watermelon units or 12 fruit mass units. He will make 12 equal pieces of the watermelon and he will find the mass of each and the relative mass of one piece of watermelon, and that with that basis he will sell it. So understand. Now you can see the atomic masses of a few elements, important elements given in the chart here. Always memorize this: carbon 12, nitrogen 14, oxygen 16, these and all you have to remember. And how do atoms exist? Mostly they cannot exist individually because they are reactive, so they will always have a tendency to combine with the same atom or different atoms to form a compound or a molecule. Okay, and the molecules or ions in large numbers form matter which you can feel or touch. Okay, and we will continue in our next session with the next concept, what is a molecule. Hope you understood these concepts really well, and do please like, share and subscribe to our channel Amazing World of Science. Many students are watching it without subscribing, or just encourage us by giving a few comments, and so that I can know how far you are able to follow the session. I hope you found the session really useful, and do press the bell icon so that as soon as I post new videos you will get notifications immediately. With that we are coming to close of this session. Thanks for watching.